So let's consider another atomic property known as electron affinity. But then don't forget, I still remain tutor Prince Obajowo Daniel Dinicole, also known as the Mathematical Arithophysical Biologist. Electron affinity is the change in energy when 1 mole of electrons is added to 1 mole of gaseous atoms to form a univalent element of negative ion. As you can see presented here, X represents the gaseous atom plus 1 mole of electron giving rise to the ionic form of that atom. But then we need to know the fact that electron affinity decreases across the period and also it increases down the group. Now, to understand it very well, or to actually attest to that fact, I would like us to consider electronegativity, because electron affinity is the energy related to electronegativity. Now, remember that electronegativity is the ability of an electron to actually attract, of an atom to attract electrons to itself. And we've established the fact that electronegativity increases across the period. So let us use this to explain why electron affinity decreases across the period. Now, looking at these elements we have under consideration here, that is period 2 elements such as nitrogen, oxygen, and fluorine, we've established the fact that electronegativity increases across the period because, looking at this trend, the trend of protons present in nitrogen, oxygen, and fluorine, we have increase in the number of protons from nitrogen to fluorine. On that note, the number of protons tend to attract the electrons when we consider the trend from left to right across the period, which means fluorine will tend to drag or pull its electrons closer to the nucleus so as to reduce the atomic radius than nitrogen. On that note, it is very readily available to attract electrons more than oxygen and nitrogen, based on that fact. Remember that we've said that fluorine will easily attract electrons to itself compared to oxygen and nitrogen, which means it requires less energy for fluorine to attract electrons when compared to oxygen and nitrogen, while nitrogen will need more energy for it to attract electrons to itself when compared to fluorine. Now, since this needs more energy, this needs the most energy, this needs more energy, and this needs a lesser energy. Now, looking at that trend, you notice that we have decrease in energy from nitrogen to fluorine. On that note, we can say electron affinity decreases across the period. On the other hand, electron affinity increases down the group. Now, to understand that fact, let us consider electronegativity once again. It is established that electronegativity decreases down the group. And this is because, considering the shell diagram of fluorine and chlorine, you would agree with me that chlorine has 3 shells, while fluorine has 2 shells, which means the protons of fluorine will tend to drag electrons closer to itself because the electrons are closer to the protons compared to that of chlorine, where we have 3 shells. These 3 shells shows that the electrons of fluorine are moving further or are further away from the protons in the nucleus. On that note, since fluorine's electrons are closer to the protons, so protons tend to drag them to itself. On that note, fluorine has more ability to attract electrons to itself compared to what? To chlorine. Now, since this has more ability or more ability to attract electrons to itself, we can say the energy required for the electrons to be attracted to this is lesser, while this one, the energy required for electrons to be attracted to it will be more. On that note, since we have less and more, considering that trend, you notice that there's an increase in the energy required for this fluorine and chlorine to attract electrons to themselves. Now, considering this is down the group. Fluorine is above chlorine when you consider group 7 elements. That's the halogen family. On that note, we can say that electronegativity decreases down the group while electron affinity increases down the group. Don't forget, electron affinity is the energy related to electronegativity. That is the energy required for atoms to attract electrons. So based on that fact, we can agree that electron affinity decreases across the period, electron affinity increases across the group. Don't forget, I still remain your tutor, Prince Obajiwo Daniel Denekol, also known as the Mathaholic Arithophysical Biologist.